Hello everyone, this is Chastity White Rose, and it's been a really long time since I've recorded a video with Open Broadcasting software. But today I am on my Linux system, and right now I am on the XFCE desktop environment, which I recently installed on my Ubuntu Linux. Let's see here, and I still don't know how to navigate it very well yet. So yeah, this is OBS right now, and I'm recording, and I've got the audio filter on pretty good. My computer's fan is noisy. I have a mini PC. There's no camera, but I trust me, you don't want to see me right now because I'm not wearing clothes. So today is going to be a programming video, and there's some programming that I have not had any time at all this week to work on my programming stuff. And there's some projects I've been working on. Okay, so here is one of my recent projects, and I'm gonna double click on this, and you see this. This is one of the versions of Chaste Tris. This is an executable here, and so this is my own game that I made, Chaste Tris, and it's actually a really cool game. It's playing itself because of the move log. If you see my previous videos, you will have a basic understanding of how this Tetris game works, because this is the legacy OpenGL version of the game. So it works the same as SDL or Raylib, but it uses all legacy OpenGL. Now I need to customize the view. Okay, let's see. Okay, I like the list view. Let's see what the compact view is. Okay, yeah, and then yeah, there's icon view. Okay, let's list view. And let's see here. There's zoom in. There's zoom out. Okay, let's try. Ooh, cool. Okay. Right. Okay, I think what I will do is I will leave it at that zoom level because yeah, I want to have the pictures big. Okay. As you can see along the left-hand side here, I have a lot of shortcut folders to various things. So like for example, if I go to the Raylib version of my game and click on this, then so that's the Raylib version of Chaste Tris, and it has music, whereas the other versions don't. Okay, oh, that's where the SDL header files are because I was looking at them. Okay, then SDL Chaste Tris 2 is here. So this is the SDL version. And notice how it has the rainbow text, and it's full screen because that's the way it's configured. I change that in the source when I feel like it, but I configured it to be this size of full screen on my computer because I think it looks cool to have a full screen. And then this is basically the same thing. You may notice it looks a little bit different than the Raylib version because it doesn't have the spinning star or the checkerboard on this one. I decided to keep the SDL version a little bit slimmer, a little bit simpler, so it's not as complex. Um, but it's still very cool. This is based pure eye candy here. This is the Tetris in its purest form. I love this. So this is the SDL version. So I already had the Raylib version and the SDL version, but then you might be wondering, well, why did I make a legacy OpenGL version of the same exact game? Well, I will explain a few things here. Okay, so I'm going to open a terminal here. That's one of the greatest things about Linux is you can right-click, open in terminal. So if I type make, it's going to compile and run the program here. Yeah, so now there's the game. Okay, so it does that, and I have a move log that it just automatically plays, that's in there, and yeah, I'm not going to explain about the move log in this video, but basically it plays back my previous play session. It's like a replay. But I use this to make sure that the game is working because I had an issue where the colors were not working. So as you see here, this displays some information. The OpenGL version is 4.6 compatibility profile. And the reason it's a compatibility profile is because it, it's legacy OpenGL I'm using. And I'm going to show you a little bit of that code. This is the legacy version. And then the font file is an LGBT file, actually. I made a joke, okay? It basically, I made an LGBT format, and it's lightweight graphics binary text. That's what LGBT stands for in this case. It is not the same as lesbian, gay, bisexual, and transgender. And I am transgender, so that's part of the inspiration. But that's some basic information about loading the image. I want to show you a little bit of the code, for example. This is, okay, notice how I have GLFW as part of this stuff. That's because the project uses a GLFW library. But if you look at this file, this is the LGBT file here. So I made a structure, and this structure has 4 elements. It has the width, the height, the bits per pixel, and the pixels pointer. And so here's the thing is, this is a function that reads the data from a file. It opens the file with fopen, and it expects certain information to be there. Because I created my own file format, this isn't something you'll typically see. But this is not a bitmap file. This is not a PNG file. This is not a this is not a JPEG. This is not any existing file format. It's my own format. But basically, the first 4 bytes should be LGBT, and if they are not, then it's an error. The next 4 bytes are going to be the width of the image. Then the next 4 are the height, and then the next 4 are the bits per pixel, which currently are kind of ignored, actually. Like, I put it in there, but it doesn't use them. But anyway, it loads the image, and it then it reads each individual pixel is what it does. But what it does is see it's supposed currently it's a 2-color image basically, such that what like zero bits are black and 1 bits are white. That's basically how I have it. So it does it. It reads it as a 1 bit per pixel image is what it does, based off of the PBM format is actually what it's based on. And then this is a structure, as it explains in the comment, an SDL rec structure, because a lot of this code is copied from the SDL version of Chaste Tris. SDL is not required, but I have the rectangle structure, and this ports it easily. So I specifically made this because I was trying to port my font library from SDL into something that would work with legacy OpenGL. So here is the LGBT draw text. So what it does is it takes the argument, the string that we're drawing, the starting x and y coordinates, and the scale. And the scale can be modified. And see, this is all just for the text. Like, it sets up the source rectangle of where we're copying from the image that's loaded. And then we still have to set up the destination based on the arguments given. Like, I swear, this is like a gigantic function. It's just a gigantic function. And it has to correctly get the color. The LGBT main color is the current color set. And okay, notice what this does here. What it actually what it actually does is that it this is GL color 3UB. Now this is OpenGL commands to set the current color, and GL recti is actually this is very interesting because it draws a rectangle using these 2 points. So the X and Y location of one corner, and then the X and Y location of another corner. And so it's hard to read because the spacing isn't really done. I could correct that. But anyway, the point is it works. And that's just for the text itself. So, when we're talking about, the text itself, as you can see, it works. It draws all the text, and I have a similar system no matter which library I'm using. But this is specifically made for Legacy OpenGL. It draws all that text because the text is a super important part of the game, obviously. But the blocks themselves are where the real magic is at, because this is the file that controls everything about the core of the game. And it's over 12 kilobytes. And see, I have a Tetris grid structure. And technically this array is much bigger than it needs to be, but we're just going to ignore that for now. And like, I swear, all of this code, in this whole big file controls every aspect of the game, including a large array for the move log. An empty color equals 0, basically. And then I have the blocks. It's all predefined code. It's all arrays. Obviously, if you look at this, you can tell I'm a pretty experienced C programmer. You can just tell. And let me make sure my video is still going all right in OBS. Yes, it is. The audio is working. Everything is going great. Things are running like a dream on this computer. Okay, anyway. But as you see, all of this code that has all the information, the colors of the color of the blocks, the ID number of the blocks, the ID character of the blocks, absolutely everything is included here. And then the width. So like this is the O block, so it's a 2x2 block. That's why the max block width used equals 2. And so it took me so long to write the code for all of this. It took a really, really long time to write it. But yeah, because it had for the collision detection. So that's just responding to the block. You know, I have all of this stuff, all of the collision detection. So pixel on grid, it has to check if we're trying to check whether a certain location on the grid, if it is less than 0 in X or Y, that's an error. If it's greater than or equal to the grid width or height, which are just global variables, then that's also an error. It doesn't print the error messages because I commented them out, but it does work. Anyway, so otherwise it will return that specific element, and it's based on whether it's 0 or not. So like, this is all just collision detection. I wrote all this code myself, and you have no idea how many months it took me to get the code just right. I spent a long time on this. But as you can tell, this is a lot of code. And by the way, all my code is open source. All of this code that you're seeing, every file, in fact, almost all of my programming code that I've ever written in my life is on GitHub. It's open source. Anybody can use it. Not that anybody cares, because this is my love child. Like, I swear, this is my child, like my computer programming code. Like, I do everything. It took a really long time to get this to work. But the main thing is the code remains the same as far as that goes. Also, I'm sick, so I cough a lot. But the main thing is the code for the actual core mechanics of the game is here, and this is the file for saving and loading the game. But the and then the input and graphics are the main thing that we need to think about. So the input, because the GLFW library is used, the GL framework basically. This is all just the functions for this is for the title screen, so that it will break and go to the next screen if you know, escape or enter are pressed. And then this is the key callback for the game itself, you know, so that it detects all these different key presses, and there's different keys for controlling the save states. Basically, I to save the state, P to load it. And don't ask me about those seemingly arbitrary. There's a reason for it based off of the BizHawk emulator, but that's a long story. Okay, and then this is what reads the commands from the move log, and based on what those characters are, it does various things. But anyway, So yeah, I have a lot of stuff going on here. So let's see here. Oh, there's actually okay. There's oh I see. I've got like a little taskbar on the top of the screen. So this is the OBS. This is the terminal. This is oh I like this. I love Linux. This is so cool. I'm still learning how this desktop environment works. But anyway, what we want to do is we want to look at the graphics here. This is the okay, so I can't show you the whole file. That would take like it would take like 20 full 24 hours just to explain all of the code. But anyway, so here is where it gets interesting because so this specifically is where we are extracting. So it's getting the gets the pixel, which is the color. It's a 32, well, basically a 24-bit color actually, in a 32-bit integer. So it gets that value at that element of the grid array, and then it extracts the red component, the green component, and the blue component. That's what it does, and then it calls this function glcolor3ub. This is a legacy OpenGL command that will change the current color based off of bytes 0 to 255. So let me show you an example. So let's say if we change this R to a 0 so that red is always 0. Well, then it's going to change it. So I'm going to show you this. You see that? Are you starting to see how weird it is? I completely altered the colors of the game just by changing one thing. And some of the blocks are invisible. It's funny how that works. Whereas if I were to change it to a 1 and do that. Oh, yeah, that's the same thing. That's right. Because 255 is the max value. Let's try this. You see that? You see how weird that is? I have completely altered the colors. That's the thing about OpenGL and about graphics programming in general is I have like full control over all of the colors. It's actually super amazing. And of course it doesn't look right when I do that. But and if I do 256, well then it'll wrap around and it will become 0 again. So and here's another thing that can be done. Is let's change the red to be equal to whatever the green is. Isn't that just the weirdest thing you ever saw? Like, I've completely corrupted my Tetris game. So, obviously, this is what it is. So, red, green, blue, that's the order. So, the colors are amazing. So, that's the way it's supposed to look. But what happens if if instead of red, green, blue, what if we do blue, green, red? And those letter variables are just kind of arbitrary, but I use R, G, and B obviously for my color components. So now that we swapped the red and the blue components, we have just completely altered the colors of all of the blocks because it extracts the colors and then it sends to OpenGL what those color values are that it's supposed to use to draw the next rectangle. And all the rectangles are a square in this case because it draws 4 squares for each Tetris block precisely. So at least the T blocks are still purple or magenta. They haven't changed, but the color of everything else has changed. So anyway, let's change it back to the way it was. Let's change it back. So now the colors are back the way they're meant to be. That's the way it should be. But now, so that's for the colors. Now this is GL recti. Okay, so that's a little bit weird. That's very weird, isn't it? Because here, here's where it gets interesting. Because GL recti is a legacy OpenGL function, and what it does is it actually draws a rectangle. So this is legitimate. Now it takes integer commands. This is basically the published OpenGL legacy version. But so if I were to change something here, okay, actually, wait, the width and height is going to be the same. So, so here, okay, so here's an idea. Let's change the rectangle width to be the block size divided by 2. Let's just see what happens if I mess it up. I'm basically corrupting my own program for the purpose of demonstration. Now, isn't that the freakiest thing? See, that's freaky. That's completely freaky, people. That's funny. Because it no longer looks right. I've completely altered it. Okay, so let's try, I'm trying to, okay, let's try changing them both to be divided by 2. Okay. Yeah, okay, come on, you gotta admit, guys, that is pretty cool. Now, what if we have one that's divided by 2, the other that's divided by 4? Okay. Yeah, anyway, we're going to stop that, obviously. And we're going to get the program back to how it's working. This is the way it's meant to work. So now it's back in its original state. However, this is just the published one that's available on itch.io. There's a few other projects. So here's the one I was just showing you. This is GLFW Chaste Tris CL. Now you may wonder, well, what does CL stand for? Basically, Chastity's library or Chastelib. Basically, that's it. So here, what we're going to do is, okay, we're going to open a terminal in this folder, and we're going to do something here. Okay, now this is very interesting because actually, things have been the game looks the same, but there is a very key difference. We have split the code into different files. So the CL file here is, there's two things. So this is the create window function. So what this does is this function creates the window. So what it does is it establishes that we're using a version 2.1 of OpenGL. It creates the window. And, well, here's the thing. This comments out glortho. Glortho was a command that I used in the other version. And in fact, let me go back and show you the other version, in fact. So back in here, we didn't have the CL folder, and we had all of the code for establishing the OpenGL context was all within the main function, but it got kind of unmaintainable. It got really kind of hard to maintain the code. So I left it, and it used the glortho to set up a 2D orthographic matrix. But the new version that I was showing you does not do this, in fact. So what it actually does instead, and this is the genius of it, is, okay, so anyway, we are in the right thing here. So what it actually does is that when we have a rectangle drawing function, and this is actually, but instead of calling actual OpenGL commands, I have my own library of conversion commands. So here is clrectf, and it does the same thing as glrectf used to do, but it still calls glbegin and glend, but it does clvertex, and clvertex is chaselib vertex. And here's what it does is it calls glvertex every time you do clvertex, but it transforms the coordinates from orthographic two-dimensional coordinates to the OpenGL coordinates, where 0, 0 is in the center, and there's positive and negative, and all ranging from -1 to +1. Now you may notice something. Notice here that in CLY we're returning -f. So it's returning a floating point in both cases. CLX is for the x coordinates, and CLY is for the y coordinates. So let's change this from negative f to just plain f and see how it affects the program. Hey, it's upside down. Notice how everything is upside down? That's kind of freaky, isn't it? Yeah, that's pretty freaky. Yeah, something about that is just bizarre. Okay, and then let's change it back to the way it was. Okay, so now that's the way it's right. So now what if we change the CLX function to return negative f instead of, ooh, now it's backwards. It's mirror imaged. I mirror imaged all the text in my game just by making f be a negative instead of positive. All the text is backwards. The entire image is backwards. Anyway, and yeah, so that's the way it works. So here's the thing: is this is the legacy OpenGL version, and so it's still using legacy OpenGL commands, but it's using my own functions instead of GL ortho. It is transforming them with my own functions, and I did this first of all to make porting to the modern OpenGL easier. Second of all, because I wanted to be able to do stuff like that and flip things and have full control. But here's the thing: is the formula is a little bit hard to explain. Um, I would like to explain the formula, but I feel like I would need to do it in a text form because just doing it in a video is hard. But anyway, this screen right here is very important because this right here is the core of what makes my game work because it has to draw the rectangles correctly. But this is the legacy OpenGL version. What about the modern OpenGL version? And believe it or not, there actually is a modern OpenGL version. And it works a little bit differently. So we're going to go up a folder. Okay, and then we're going to go up again. We're going to go to GLFW Chaste Tris CL Core. Now this is core because it's core OpenGL, and that means it's the modern kind. So if we go in here and we do make, now notice that it looks the same. It looks, oh, ooh, it says chastity checkerboard. It's not supposed to do that. So apparently, I still had, yeah, it says chastity checkerboard. That is not what it's supposed to say. In fact, let me go back. I want to try something. I want to go back to this one and see what the title, OpenGL Legacy. Okay, that's what it is. Okay, OpenGL Legacy. Okay, so what we want to do is we want to go back and we want the new one to say OpenGL Core. Okay, so what we're going to do is that I have the same files here, but things are a little bit different. So we're going to go to the create window function here, and we're going to change that. Now notice when I go to the create window thing, this is modern OpenGL. So I actually stole a lot of this code from Anton's OpenGL 4 tutorials. I bought his Kindle book, I looked at his website, I looked at examples, and I was able to get this working, and it took me a long time. But anyway, this is, so, so it tries to initialize GLFW, it tries to create an OpenGL context, create a window, and then, it makes the context current, and then it loads glue, it loads modern functions. Then for example, okay, anyway, we're going to change this part here. So, OpenGL core. Okay. Okay, so now if I recompile it, now it says OpenGL core. I don't know if you can see that on the video, but it says OpenGL core. But it still works pretty much the same. It looks the same. But everything is different because the way that the code has to operate is different. And I will explain what I mean. Now, it displays the information about the OpenGL version and the renderer and everything. AMD Radeon Vega 8 graphics. Apparently, that's my GPU. Okay, and it still works. Most of this still works the same, including the font library, but it does things differently. There's no GLO ortho, just like the other, but it has to do everything. It has to enable things. It has to generate a vertex buffer object and a vertex array object and every crazy thing. Um, so it does things for the array of colors um, and the array of points, and so it's very complicated stuff. And a lot of this won't make sense. It still doesn't even make sense to me, but I got it working. Has to generate the vertex arrays. Has modern OpenGL is a real pain in the ass. It's not at all easy. And this actually doesn't do anything here because it doesn't really work. And I can prove it because this would normally make the screen gray, but it doesn't actually really work. Oh, wait, it actually, oh, I guess it actually does work because the clear color still works in modern OpenGL. Okay, yeah, that's kind of freaky. Okay, so it does work, but the default color is still black. And I prefer my background to be black because that's the way it was in the old DOS days. And on most Linux terminals, the background is still black with white text. Okay, so anyway, it works, but the real difference, besides the fact that we're using modern OpenGL for everything, is that the rectangles have to be drawn differently. So here's the core CLRect. I wrote all of this. Now, we're going to go to the top. So you will notice, actually, before I get started with this, I'm going to use the restroom and I will be right back. And let me see here. Okay. I'm going to be right back after a short bathroom break. All right, I am back. So now what I want to show you, and we're going to make sure everything's still going right with the recording. Yes, everything is fine. Okay, so notice that, and the comments need to be updated, obviously. But notice these first two functions are the same. They work exactly the same because we're transforming orthographic coordinates into OpenGL coordinates. Now, this is where it gets kind of freaky. Notice that we have a CL3UB function. And the reason for that is because we can't use the old OpenGL functions. Instead, here's what we have, is we have a vertex index equals 0. That's at the start of the program. It's 0 anyway, but we have a vertex index and we have a color index because we are populating arrays of vertex positions and colors. So we actually have global values for red, green, and blue. They start out as all ones. And then this function here is actually very weird. And I'm going to show you something. If I if I uncomment this out, I will be able to show you something. So notice how it has all those information about the colors, no, and it changes rapidly. It goes way too fast to actually be able to see it. But that's just was for my debugging purposes. So anyway, okay, so we have, instead of calling GL vertex, as you can see in the comment, that's the way it did work. And I'm going to change this to be a, change that to be that kind of comment. What it does is there are separate arrays for both the points and the colors. And the color is written in British style because apparently Anton is British or something. Anyway, so that's funny. So here's what we're doing is, let me show you the, okay. Oh, let's see here. Okay, so here I'm gonna go back up a directory and I'm gonna show you the main.c file. So here we have, at the beginning here, we have several global variables. We have the points array of the points. It has initial default values, and then we have the colors. And so it gets very interesting because it all started because I started with Anton's triangle example. Then I extended it to be two triangles so we could form a square, and it turned into a huge mess is what it turned into. But anyway, and then this is my vertex shader. I actually embedded my vertex shader into my program, and my vertex and fragment shader. Now, what I did is that I copied bits and pieces of two different parts of OpenGL tutorials by Anton. And needless to say, it obviously works, but we have we have the vertex position and the color as layouts. It's kind of freaky how that was, and there's all these things. There's a vertex shader, there's a fragment shader, and all of this stuff has to be here before we include the create window and the clrect.h files. And so that's all the graphic stuff that has to be included. These are my own files, whereas the include files up here are system files that I've installed. We have the width and height of everything. So anyway, it's a big program. It's a massive program, and then I have my own custom CL library, and then we get into the actual operating for the game itself. Um, so you might be wondering, well, how does this work? Okay, so I'm going to attempt to explain how my program works, guys. This is really, really hard. So here's what it actually does. So every time that we call CL vertex, what it does is it is going to fill that specific vertex with those arrays. We have three dimensions: the x, y, and z, and we're doing two-dimensional, so z is always 0.0, and it just increments the vertex and everything. Vertex index. We have the color index. So it uses the global variables for red, green, and blue, and it's the CL color 3UB section which sets what those are, because they have to be in the range from 0 to 1 for OpenGL to understand it. So it has to, my function converts between these different things. It's kind of funny how that works. But anyway, so every time we do this, so then what it will do is, so it works. So the clrect.f function works very similarly, except what it does, and obviously the spacing of this is wrong. Obviously I have wrong spacing on this. I'm going to fix that. Okay, so basically, here's what this is doing. The clrect.f function is actually calling It's actually it's defining two different triangles. It's defining two triangles and populating the array, which is just big enough for two triangles. And there's three components. There's three floats for this, three floats. Yeah, okay. So yeah, so there's a total of six floats for the position. And so, but we're doing position and color. So first we have to send to the GPU the buffer data. We're binding the buffer, and then we're sending the data for the positions or the points. And then we're sending the data for the colors. Okay, this is interesting because, and then it draws the GL triangles. It draws triangles using those 6 points that we've defined and we've sent the buffer. But what happens? Okay, we're gonna try something. What happens if I comment out the part about sending the color data? Well, we're gonna find out what happens. Uh, okay, that's a little bit freaky. The text is there, but it looks funny. See anything bizarre about this? It looks beautiful, but you can't actually see anything. But what you can see is you can see that each square is in fact made of two triangles. And they're gradient triangles at that. So it looks really cool, obviously. It makes the game unplayable, but it does look cool. So let's try, what happens if we also don't send the point data? Oh, how interesting is this? How do we get this shape? Well, the funny thing is that is the original statically done thing. So that rectangle is actually defined in the main.c file. So if you see up here the points here, this is the defining the two triangles. This is all direct OpenGL coordinate data for these two triangles. So let's say if I were to change this from, what happens if I change the 0.5 to 1.5 here? Let's just see what it does. Oh, see how it actually draws it off the screen somewhat? That's funny. So we have 0.5. If we make this 1, it, yeah, okay, let's see here. See how it does that? I have modified the shape of that triangle. But obviously, I want it to go back to the way it was. But anyway, I set up this array so that we would have a specific rectangular shape if the values were not modified. And so that's what happens. And so then that will be all it draws. And also it's important to understand that it only works because of the fact that we do send the buffer data at least once. Because if we go to this folder in the create window, let's go to, okay, let's see. See, here's where we send the buffer data originally. If we don't send the buffer data for the colors originally, we get nothing. Doesn't do anything. We have to send the buffer data at the start of the program at least. So that's why it does it. Yep, it doesn't work. If we don't send the buffer data at the very start of the program, then it doesn't do anything. So anyway, but that's the basic idea, is that my set of utility functions is meant to populate that data there. So it sets up the colors there and the points, and it just has to work. If any piece is missing from a modern OpenGL program, it just completely fails. Whereas with legacy OpenGL, you can get away with a few things because it's simpler. But anyway, yeah, and the same thing could be done here, modifying things. Now, here, for example, let's say that if we did not set let's say if we did not set the red component in this, then it just ends up being 1 constantly. That is really actually very weird. That is weird looking. But anyway, so anyway, I want to show you exactly where these things are called though. So we're going to go to the graphics section here. We're going to go up the folder and we're going to go to the GLFW graphics, and this is for the core thing. So we're going to go to, yeah, let's see, CLRectF. Okay, so that's for drawing the grid. We're going to go, this is the same portion of code I showed you in the legacy OpenGL one, except it does something different. The CLRectF function is named the exact same as it was in the legacy OpenGL thing, but instead it does all of this. It does a whole different thing. Instead of GL begin and GL end, it's using my own special CL vertex functions to set the data just right, and then bind the buffer and send the data. It does a lot more work, but it works the exact same way as the final result. So notice we have CL color 3UB because it's still extracting the colors from the block data the exact same way, but then it's calling CL color 3UB instead of GL color 3UB. So this is interesting because the source code is mostly the same. Like the code is almost identical to the legacy OpenGL version. Okay. So here's something I want to try. I want to try something, guys, and what I'm about to do may completely mess up my program. It may totally mess it up, and but I have backups on GitHub anyway, but I'm gonna do something. So here's the core version, okay? So what we're gonna do is we're going to open a new tab. So we're going to go to the legacy OpenGL one. What we're going to do is we're going to, because the GLFW graphics, this is the main thing. I made a copy of that file. This one is 3.1 kilobytes, and that's the legacy. What happens if we copy the core OpenGL one over to the legacy one? There's a difference of about 40 bytes. It's slightly bigger. I must have changed something. We're going to replace it, and then we're going to, okay, because I'm still in the terminal for the core one, and that's why it's so important that the title bar tells me whether it's core or legacy. That's why it's important that it does that. But now what we're going to do is now that I'm in the legacy OpenGL one, we're going to open a terminal in this folder, and let's see if it compiles and runs. Oh, it does not run. You see that? Okay, warning, implicit declaration of function glcolor 3UB. Ooh, how interesting is that? Now, here's something I want to show you also. Because obviously there is no CL color 3UB in this thing. So, but I'm going to show you something. So first of all, what I'm going to do is I'm going to open up the backup file in Visual Studio Code. And there's a reason for this actually. So, oh, and it makes me enter my password. Okay. So, okay, let's find GL color. Okay. Now, actually, this is weird. Now, it's saying, yeah, it's saying it can't find it. So, we need to, okay, here's what I actually have to do is I actually have to open the folder, so that then hopefully it will work correctly. Okay, because now that it should get rid of errors. So here we have, I'm in Visual Studio Code right now, by the way. So let me find where CL color is. Okay, GL All right. Okay, yeah. Why is it acting funky on me? I don't know why it's getting so funky. Okay. GL color. Why is it saying that? Okay, I don't even know why it's doing that. That's a little bit weird that it's doing that. Because it worked before. Okay, so let's see here. Now here, everything is okay. Yeah, let's go to. Yeah, I'm still trying to figure out why. I don't understand Visual Studio Code very well. I really don't. So I'm a little bit out of my element. So, but I specifically remember. Okay, so here's CL color 3 UB. And let's see, let's go to definition. There is no definition for it. It's a little bit weird. So here's what we actually have to do. I still I still don't know why it's saying there's no definition. That's a little weird. Actually, I think hey, okay, I have an idea. Okay, first I'm going to open this file here. Okay, so then what we're gonna do here is let's go to okay, GL, yeah, okay, we're gonna go to definition, and then we're going in this create file. So let me just find the right thing here. We're gonna go to the definition. So now we are in gl.h. Okay, so this is like gives you basically the information. So let's look for GL color. Okay, okay, here we are. GL color 3UB is what I'm looking for. Notice this says GLU byte of red, green, and blue. But what is a GLU byte? It says type def, unsigned character, yeah, GLU byte. So I do this, yeah, so that I know, yeah, okay. Let's see here. I'm trying to. So here is where the type def for it, we know it's an unsigned character. We know that much. And that's the information I need to know. And I still want to know exactly, I want to see where, okay, gl.h is in user include GL. Yeah, GL, obviously, OpenGL has this, and there's free glute, there's GLX. There's all kinds of great things in here, stuff that I don't understand. But anyway, I don't need to look at all of that. So here's what we do. Now that we know it's an unsigned character that we need, I'm going to do something. I'm going to, okay, I'm going to close, okay, I'm going to close Visual Studio Code because I'm not very good at it. But okay, look at this. So here it says implicit declaration of function CL color 3UB. Did you mean GL color 3UB? Well, here's the thing. We are going to make a function. Okay, we're going to make a function for CL color 3UB. So what I'm going to do is I'm going to copy, because we did have a function by that name in the core version. We totally did in my rectangle function. So we're going to copy from the core function and CL color 3UB. We're going to copy this function because it actually did, it worked on the core version. But if we try to copy from the core version into the legacy version, we may get some unexpected results. We just might. So here's what I'm actually going to do is I'm going to put it down here, and there is a function CL color 3UB, and none of those variables exist. They're not valid. So here's what we're actually going to do. What we're actually going to do is, see, we had I know what I'm going to do. We're going to, yeah, see, I'm thinking in my head what I'm doing here. So what we're actually going to do here is we're we're going to instead of CL color 3UB of red, green, and blue, we're going to simply copy that name. It's going to be GL color 3UB. It's going to literally call the GL color 3UB, and it's going to be red, green, and blue. So let's see if it works. Actually, we're going to try and see if it works. Hey, it works. Hey, that's oh, I see. It doesn't exactly behave correctly entirely though, because the program is still malfunctioning. And part of that is because it's calling CL color for the title screen, but it's not. It's acting a little bit weird. So here's what we need to do here. We need to find all of the occurrences of where it says geocolor 3UB, but I'm also going to do an optimization. We're just going to have these R, G, and B. So we're going to just shorten these just to make the code shorter because it's pretty simple when you see RGB. It stands for red, green, and blue. There's no need to have them be all special and fancy. So anyway, so we have it working, but then when I press enter, it's doing things and it's not. So clearly, because this is the legacy OpenGL version of the code, and so yeah, so we're still in this. Okay. So anyway, yeah, let me close out of that. And then I need to, now that I have a working function, we're going to go into the GLW graphics here. Okay, first of all, okay, CL color. Okay, so interesting. Yeah, so that works for that. But let's see. Do I have any occurrences of GL color? Okay, CL color. Okay, so I mean, now it's interesting though because notice that all that I actually changed. Oh, I think I know. Wait a minute. Okay. So obviously something weird is happening because it's not clearing the screen correctly. It should at least clear the screen. So let me figure out the source of this because okay, so let's go to okay, GL clear. Interesting. Okay, I think we may have found something because so let's look at the copy. So let's look at GL clear. Okay, notice in the this copy we just had GL color buffer bit. It is clearing, whereas in this one it's trying to clear the depth buffer bit and the okay, that's a little bit weird because I wasn't even using a depth buffer bit in okay, that's that might be part of why it's messing up. Okay, so let's try something. I'm going to try seeing what happens here. Okay, it still isn't behaving exactly right. Yeah, it's behaving kind of funny. Yeah, that's a little bit weird. So maybe that wasn't actually the issue. Yeah, that's strange. Um, Maybe, okay, maybe that wasn't the issue. That's a little bit weird. Because obviously the title screen is working correctly. But when it goes to the next screen, yeah, see, now I am diagnosing a little computer problem here. This is weird. So, huh. Okay, so first of all, um, I don't see any reason why that would necessarily mess it up. It should be drawn correctly, and yet it isn't. Okay, and let me try something. I'm gonna see. Okay, so here is the new one. So let's look at the title screen. Hmm. Yeah, I'm trying to figure out what's happening here because okay, GLFW text. Okay, so here. Okay, so here's where the text is for this here. Okay, so I think we're figuring out. Okay, so obviously it works correctly when so when we are drawing the okay, so it does clear the screen at the start here. It clears the screen when we first start the program here. Um, okay, because actually let's try something here. Oh, I don't have C++ style comments enabled right now. Okay, let's see here. Okay, yeah, that still works. So I'm trying to figure out. So it is drawing the text there. It is, but we may need to figure out something here because yeah, I'm trying to figure out what's wrong exactly. Okay, yeah, because clearly I messed up my program. But how did I mess it up? Exactly what was it that I did that messed it up? Huh. See, this is where I'm trying to figure it out. Because it worked until I changed just that one file. The because in the original file we had GL color 3UB there and there. So it should work correctly. It should be working correctly. But for whatever odd reason, it isn't. That's a little bizarre. I wonder why it's doing that. Hmm. Yeah, see, now I have a real big programming problem on my hands. Why did it stop working? Because now, see here, in our brand new file, it CL color CL color yeah, there and there. So it should work correctly. It totally should work correctly. And yet it isn't. That's a little bizarre. Wait a minute. I think I may know. I think I may have figured something out. Okay, so in this one we have GL flush. Okay, so GL flush here is used here because that was the way I had it. But in this new one, do we have GL flush? Oh, we do not have GL flush. Oh, okay, I get it. Instead, it has GLFW swap buffers. Okay, I see now. GLFW swap buffers. So here's what we're going to actually do. To make things consistent, we're actually going to make sure that the buffers are swapped in the program instead. So there is actually a big difference here. So it's trying to swap the buffers in a system that's set up for I have a single buffered system set up here. So I think I know what's wrong. Okay, so because if we go to the create window function in the core version, so okay, 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 because I'm trying to set up. Okay, so let's see here. I'm trying to figure out because we want the window. Okay, so okay, where is the create window? Okay, create window. Okay, so it's initializing OpenGL. This is the modern version. It's doing all of that. But yeah, and see in the modern version, it does everything is swap buffers. So like for example, in the in this version, let me see here. Okay, yeah, I'm trying to figure out exactly what is wrong with my program because I corrupted it. But I shall find the answer. So we're gonna go here. So in here, let's see here. So okay, so yeah, swap buffers. So we did have swap buffers there as well. Okay, so yeah, how interesting is that? Okay, so here's what I'm gonna do. So first of all, I'm gonna try something. We're gonna go back here. Let's go back to this one where it has the swap buffers, and let me try something. We're gonna try GL. Okay, flush. We're gonna see what happens if I put that in there, if it works right. Hey, see, then it works right. Then it works correctly. However, swap buffers is the way that it works in the core version. Okay, so here's what we're gonna do because we want it to work identically. So what we're going to do is, first of all, I'm going to copy over the GLFW graphics thing straight from the core to the legacy. We're going to try this again and revert all my changes. So, and we know that it isn't working. So here, okay, I think I know why this is. So, and that's because in the legacy version of my OpenGL program, I set up single buffered. Okay, so we're going to go to the create window function of my legacy OpenGL one. Notice how it says GLFW double buffer, GLFW false. We're going to make this true. Okay, actually, yeah, we're going to change from false to true. So now, see how that is? So now it doesn't actually, it doesn't work correctly on the title screen, but it does work correctly for the game itself. And now I know exactly why. We need to make sure it's true that it's double buffered so that we can swap windows. So now that I have figured out the solution, we just simply have to change. So we're going to go to swap buffers. We're going to copy and paste this text, and every occurrence of swap buffers has to be of GL flush. So we're going to go to this part. Now, for the welcome screen, we need to change GL flush. Flush all, yeah. Yep. There we go. Yep. Flush all GL commands and display the screen. So now that I've done it and we're swapping the buffer of the window in both the title screen and the game itself, now it works. So now that's the beauty, is we're using the exact same graphics file for the core version as we are for the legacy version. Yes, it's working, people. It's absolutely working. So now both the legacy version of the game as well as the yeah, and see this yeah, so that's for the title screen. Now this is for drawing the stats of the game. So it doesn't actually need to swap buffers because the buffers are swapped in the GLFW graphics thing. So now that we have double buffered in both legacy and the core, it works. So here we have this is OpenGL Legacy Chaste Tris, and it works. And now, and see, what we did is we created in the CLRect file for the legacy, we created CLColor3UB, which calls GLColor3UB with the exact same arguments passed to it. Just like with CLVertex2F, we're calling GLVertex2F, but we're using my transformation matrix there. Okay, so I got it working, people. So now, just for review, we have the legacy version of Chaste Tris, which works here. And then we also have the core version. So if we, just to make sure everything is still working, yes, it actually works. So OpenGL Core and OpenGL Legacy. And the thing is, I could try to add the rainbow text to this game as well. The only thing is that I feel like it would kind of pollute it. I feel like it would kind of pollute it because I would have to add an entire... See, in order to do the rainbow text like the other version of the game does, I have to add a whole lot. I would have to add an entire another header file. Like, because in the SDL version, it has to have Chase the Rainbow. So like, it works in the SDL version, but that's because it has a whole lot more work to do. This is the SDL version again. So, because Chase the Rainbow is a special file that was made specifically for use with my Tetris game, it makes a rainbow palette and keeps track of that palette. So it's a little bit weird. It doesn't work exactly the same. So I'm thinking that I will keep my yeah, I think I will actually keep my OpenGL code without the rainbow text, because it adds a lot more CPU cycles because it has to keep constantly changing the color for each square of each text. So it actually is very inefficient to do so. It's not a big deal when using SDL, obviously, because it's doing a whole different system. But and if I wanted to add the rainbow text to the OpenGL version, I could, but I feel like I don't feel like adding another 5 to 6 kilobytes to my program just for the sake of rainbow text at this point. Plus, you can play the Railib and SDL versions, which have the rainbow text. There's even an Allegro version. So anyway, but anyway, we have a working version of the game, and notice the title screen is identical. GLFW is used for the OpenGL context. Yeah, so this is the core version of the game. The game is fully functional and playable. And then here is the legacy version. And they're meant to work identically. And obviously we don't need this extra file anymore. We should not need that. But anyway, obviously I have made some changes to my program here. So what I like to do before I end this video, there's something very specific I want to do. Is I want to make sure that everything is backed up perfectly. Oh, and I'm also going to show you the Allegro version of Chaste Tris just for the fun of it. We're going to open a terminal there. We're going to This is the Allegro version. It uses Allegro, and it works pretty much the same way as the Raylib and SDL. I've made the exact same game using several different frameworks, even including legacy and modern OpenGL. And keep in mind, my modern OpenGL is by no means modern, and it's not three-dimensional either. It's just a very simple thing. I basically use OpenGL only for two-dimensional graphics because I don't know the trigonometry and all the advanced math required for 3D graphics. How interesting is this? Yeah, that yeah, that's a little bit weird. Oh, I think I may have frozen my uh okay, yeah. Anyway, I'm going to Okay, yeah, I'm gonna close the entire window here. I think I may have tried to run a messed up executable here. I may have messed it up slightly. And we're going to exit out of here. But oh wait. Okay, so there's OBS, and then okay, first of all, where's the task manager? I feel like okay, I messed something up here. Um I think it's trying to run something. I may have frozen my computer up a little bit with something I did. Wait, let's see, what's this? Yeah, what kind of Okay, wait a minute. Okay, I'm going to Okay. Okay, yeah, yes, that's what we're going to do is we're going to close that program. I think okay, now I've got it back to normal. I don't know what happened there, but what I'm going to do is I'm going to go down and I'm going to open my web browser and okay, I'm going to go to GitHub. Gonna go to GitHub. Oh, this is a one-time verification of your recent configured two-factor authentication. Let's see here. Okay, let's just see here. Okay, they sent me a text message. Oh, I have to turn on my phone. This is frustrating, guys. Okay. See, this is frustrating. Personally, people, I just wanna have a short little rant here. I personally hate two-factor authentication, because it makes it so annoying and hard to get into my GitHub account. GitHub now requires two-factor authentication to log into your account. So, yeah, and you're not going to see this because you shouldn't see this. This is security wise. But, but anyway, I got the code on my phone. So now, if I enter the code they sent to my cell phone number, then, okay, 757, okay, 799. and it's going to be different every time. Okay, verification successful. Now they will let me into my own account. It's so frustrating, guys. Now I want to explain something here. Oh, someone who's a Linux developer and a VTuber. I'm totally going to follow them, whoever they are. Anyway, I want to show now my main repository that has Chaste Tris. It explains everything about my game Chaste Tris. It is all this has the Rayla version, has the Allegro, the SDL render version, as well as the original SDL using services. All of my other Chaste Tris versions and all the source code for all of the editions of all the others, including the readmes about the music licensing and everything. Oh, there's interesting files here. Anyway, those are all on the Chaste Tris repository. So if you look at here, go to github.com/chastitywhiterose/chastetris or Chaste Tetris, whatever way you want to say it. So, but if you go back to my actual list of repositories, because I have all these different repositories. I have all these different projects. Only I really know how this stuff works. Most people don't even know anything about my code, even in spite of attempting to advertise it. But I have a lot of different. I even have a Pico 8 version of Chaste Tris, interestingly enough. I tried to make a Pac-Man game, and it was working, but I didn't have ghosts or anything fancy. And I even had mixture of SDL and OpenGL, which is unnecessary, but I did it for the fun of it. And then modern OpenGL with SDL. But I later started using GLFW. So GLFW OpenGL, this is the correct folder. So we have the published one that published on itch.io we're using legacy OpenGL. But now I'm going to back up. I'm going to go to my legacy OpenGL folder. And I'm going to, okay, so we're going to go to, okay, we're going to go here. Then we're going to go up a directory. So this is the CL. So because there's two different folders, okay, here's what we're actually going to do here. So every single header file, as well as the main.c file, and as well as the make file, all of this is going to be uploaded to this place, because this is the legacy OpenGL version here. Okay. But then, because I modified the source files of the CL library itself, we want to make sure that we go in this, because this was uploaded last week. So most of this is still showing as it was updated 2 weeks ago. That's because even though I uploaded them, they haven't been modified at all. So GitHub let me keep track of how long ago something was updated. So what I'm in my legacy one, but we're in the it's so frustrating. I need to add better shortcuts, but we're gonna go to the CL. Okay, so here we're gonna go to the CL folder here, and okay, yes, and we are going to the legacy OpenGL doc here. Okay, so here we have this. So and I'm going to confirm that it's correct here. Okay, so here we have this, and now we have this, and let's make sure if everything is correct here. Yeah, so okay, so CL rect, CL color. Yep, everything is correct there. And then we're going to go to the CL folder, and yeah, how interesting is this here? Because okay, oh, I had actually made a oh, I had some documentation. I was making some documentation of some important functions, That's not important to understand. And then here we have the clrec.h. So it has the correct stuff. It has the legacy code. And it's just a lot cleaner, a lot easier. So, but everything is up to date there. So now I have backed up all of my legacy GLFW Chaste Tris CL library. I know I talk a lot of this is complicated stuff. I'm trying to keep my own code straight. So now we're going to go back here and we're going to go into this subsection, GLFW Chaste Tris CL core, which is separate from the CL legacy. So now I'm going to go to the core folder here and we're going to upload all of these files. Okay, all these files are going to be uploaded to this folder just to make sure they're all up to date. Okay, that's cool. That is really, really cool. Okay, and then we're going to make sure also that we have everything up to date in this folder as well. Because I don't think anything major has been changed. I don't think there's much that's changed in here at all. But I just want to make sure everything is the most up to date. So we're just going to upload these things here. I'll probably update the README at some point. Now here's the thing. There's a lot of stuff in here. There's a lot of interesting stuff in here, and you can like it. This is GitHub, okay? So all you have to do is you can clone the GitHub repository, or you can just download a zip file, like you can totally just download a zip file of all of this source code. That's what's great about GitHub, is you can download the entire source tree. I will show you one more cool thing though before I close this out. I'm going to go back up here and we're going to go to my GLFW. So I will show you in the Anton folder here. This is Anton's purple triangle. That's what this is. This is the hello triangle thing. And it was the original example. I basically took his example and I modified it heavily, and there were other things. It's been heavily modified from the original. But anyway, all of my code is backed up to yeah, it's all just totally backed up to my GitHub, and you can download all of the code that I showed you in this video is all available. And so I have various things. See, chastity triangle, chastity rectangle, chastity checker. Yeah, here's my checkerboard example, which is super, super cool. I have a checkerboard example. I can move the checkerboard around. Yeah, see, I have the checkerboard example, and this one was actually kind of weird. Yeah, this one worked, and you can tell it still has most of the code from Anton's projects. But yeah, so I had the chase triangle. So if I open a terminal here, I can compile and run that. It worked. So that's the chastity triangle example, which is on the GitHub. It's on the GitHub, people. And then the chastity rectangle here, a small example here. Well, it's 7.4 kilobytes, but it draws the rectangle exactly as I showed you. That's exactly what it is. And then, yep, so that works. And then, yeah, the chest checker. And then this one, actually, I think this is the same thing here. Let's see here. Yeah, that's the same thing. It's bizarre though, because it's 7.0 kilobytes. This is the original version there. Has all of that complicated. The fact that just to draw that takes all that code. Modern OpenGL is hard, people. That's all I'm gonna say before I end this video. And even though I'm sick, I very much wanted to uh, do this video just to help explain some things. But basically, all of my OpenGL code in this video, you can find all of it here at github.com/chastewhiterose/glfw_OpenGL. Basically, all of this code, that after I work on it, I upload it to my own GitHub, and then I also do backups to my online storage and my USB drive. So I definitely did a lot of cool stuff today. I made major progress, fixed some problems, made some compatibility corrections between my core and legacy OpenGL version of my Tetris game. So I'm proud of myself. I feel like I made progress and I feel very satisfied. I hope this video has helped somebody. So anyway, this has been Chastity White Rose doing a programming video. So I guess be excellent to each other. Party on, dudes, and may the horse be with you. Thanks for watching. Like and subscribe. Thank you.